Okay. Now we're just gonna up it just a little bit here. They're gonna start throwing other terms at us and a few extra things. Now our given only gives us one thing. Segment SU is the perpendicular bisector of segment RT. So we need to look at this really carefully and find all the pieces that we can find. And also pay attention to what is that they want us to prove. So first of all, I notice that they want us to prove angle RSU is congruent to angle TSU. So we're probably heading towards a CPCTC moment. So we need to prove that triangle RSU is congruent to triangle TSU first. Okay? So this triangle to this triangle. All right. And we probably can put that down as something we can do. SU to SU, that's a reflexive bit there. Now let's look in here at this bit. We're gonna have to get our other two pieces of congruence from that given. Gonna have to. So what does perpendicular bisector tell us? Perpendicular tells me there's going to be 90 degrees. Bisector means cuts in half. So that's a good start. There's a couple things in there. So let's look. SU is our thing that's doing, that's our knife, is the perpendicular bisector of RT. So it's coming down at 90 degrees and it's cutting RT in half. Okay. I need to make sure I read that aloud in my head or out loud physically and make sure I know what's happening. SU is coming down at 90 degrees and cutting RT in half. So I got to mark that. It comes down at 90 and cuts RT in half. Does that make more sense? Okay. That looks like something that's solvable. In fact, those triangles look like a side angle side congruence. Okay. Now writing this is going to be one extra step further. So let's get over here and let's try and write this, okay? So we're going to put our given in. Now let's write the easy one. SU congruent to SU by reflexive. Done. All right. Now the bisector part, that was pretty straightforward. We could write that RU is equal to UT. So let's do that. RU is congruent to RT. And we have to use the word perpendicular bisector. So let's go find definition of perpendicular bisector. Well, what did I write wrong? RU, oh, I wrote RT, it should be UT. There we go, validate, nice. Okay, so I got my two segments. Now I need to do my angle. And it's really tempting to go right in and say angle SUT is congruent to angle SUR. So I'm gonna go try it. Angle SUT is congruent to angle SUR because of definition of perpendicular bisector. Doesn't work. It just doesn't. It's too fast of a leap. You can't do it so fast. What you have to do is say that because it's a perpendicular bisector, that means that SUT is a right angle. That's what you can do from definition of a perpendicular bisector. Perpendicular means it's a right angle. It also means that angle SUR is a right angle. And now you can take that extra step and you can say, and because they're both right angles, they're equal. I don't know why we have to take that extra step. Seems a little bit like dancing, but all right angles are congruent. There we go. So that's the steps we have to take to be able to get those congruent. Okay, so now we've got those in there, and there's our side angle side, and so now we're gonna write out that those triangles are congruent. I'm gonna use that same order that we have. It doesn't matter, you pick one of them. You can do the SUT to SUR, the RSU, but make sure it's consistent. It has to be in the same order that you would trace around the triangles to match the points. So I'm gonna do SUT because it's right above me in the SUR, and that's going to be the side angle side. Validate. And now I can pull out one piece with CPCTC. And we're done. There we go. I hope that made sense. It's a pretty big proof. A lot because of that perpendicular bisector and how we have to break it down.